Right, good afternoon, ladies and gentlemen. My name's AHoward. I'm Technical Director for Lighting at WSP. Also heavily involved in the lighting industry through the Institution of Lighting Professionals and the CIE, which is the International Lighting Community. I will stick my hand up. I am a lighting designer. I appreciate you are between me and the door, so yes. But I would just like to give my perspective on what we've been talking about this morning, and hopefully afterwards you will be more on my side. I have seen the number of red dots that have appeared about trying to sort out lighting designers in the next room on the question sheet, so we will see. Right, we all need light to see, and artificial light has become an important part of the 24/7 world in which we live in. Depending on the task being undertaken during hours of darkness, we need to make sure we provide the right levels of light in order that it can be undertaken safely. Good lighting helps reduce fatigue, improve safety and usability of a site. And what we've got there is a salt barn where you've got workers loading up salt, etc. during the night. But actually, when they're not using the site, the lighting level dims to half the lighting level required when they're not operating in it. It can also be used to enhance the environment, promotes well-being and helps to accommodate the 24/7 lifestyle that people like to lead. It's used to enhance the area through the use of decorative equipment, feature lighting of buildings, and helps promote economic growth. And this has been proven by footfall research within various towns and parts of towns. The image on the left-hand side is from Toulouse. They run a tour for the public one night a week, taking the public round the lighting installations in Toulouse. For some of you provided in the lighting industry, you might have attended a gas lighting tour that we did in Westminster a few months ago, and we're doing some other ones later this year because people are fascinated by the gas lighting and the history that comes with it. We're looking to light major routes, motorways and principal roads so that people can drive through them and drive safely. Research by the Highways Agency has shown that good lighting on motorways will reduce the accident rate by 11%. We light local roads more for the use of all users, letting people orientate themselves within that space and understand what is going on. Is the little boy likely to run into the road? We need to make sure people aren't just looking ahead, you can understand what's happening in the peripheral view of what's going on around you and between the cars. Old research, and we're looking at new research, indicates that good lighting in those streets will reduce accidents by 30%. In commercial areas as well as public areas, we look to provide good lighting, and that helps reduce crime and the perception of crime. And if you can notice here in the car park that is well lit, all the cars have been nicked. This is supported by work of people like Dr. Kate Painter at the University of Cambridge in the criminology department that have done a lot of before and after studies and looking at crime relocation aspects in relation to good lighting. And her research shows that good lighting will have an effect to deter crime because it attracts more people out and therefore there's a higher chance of observation. But we're only talking about street crime. Can't necessarily talk about burglaries and other sorts of crime. You've got to look at what you're looking at. If we're looking at sports lighting, we're trying to provide the right level so people can undertake the task and the sports they want. The smaller the object you play with, the higher the lighting level required. But on the other hand, we are seeing a lot of problems with the TV companies, especially saying HD, need these much higher lighting levels without any evidence to support those aspects behind it. But this shows quite clearly the fact that we've also got to control the light as part of our design process. You can light sports appallingly, and most of the poor lighting in the country is to do with sports and industrial lighting. Or you can light them very well and just make sure that the area required is lit. Use of colour. Unfortunately, we've got an industry, especially in the architectural market, where if we're going to floodlight something, we've got to go and colour change it. We're doing our best to say, let's look at what's needed. Colour changing can be good, but the use of colour can also be awful, like you can see in one of the photos just there. But it can also be used to enhance areas, etc. So it's a matter of understanding what is really going on around. So that's lighting. But as a lighting designer, I wish to say doesn't mean we want to light everything. The picture down there is a little remote footpath up in a small village in Scotland. There's a housing estate being built down there, and the developer wants the footpath lit. And it was quite a discussion from us, so why? It doesn't need to be lit. You know, there are other ways that the residents can get in and out of the estate as opposed to just do this footpath, because it is quite overgrown, but there's a lot of wildlife down there. The other aspect we also talk about at the time is, can it be moved? I looked at a housing estate plan recently that was coming through, and there was concerns about back corridors, and they wanted the footpaths moved, but you had the houses, area of grass, footpath, hedge. So let's move the footpath over to beside the houses, then you've got the grass area before the hedge where there was the backflight path. So let's do that as a mitigation measure. As you've heard earlier, we have a wide palette of light sources available to us. We go from the low pressure sodium lamp, which at this current stage under British standards we can't use. It's been ruled out of the European and British standards, but we've got high pressure sodium, we've got LEDs, we've got induction lights, and we've all heard about the spectra difference that they can produce. But unfortunately, what we've got at the moment, we have an industry that's very good at leaping on the latest technology. The first thing we get from most clients is, I want to use LED. But what we're trying to get across is, let's understand the task, how the task needs to be lit, and then find the appropriate technology to actually use. It may well be LED, but it might be high pressure sodium. Do we really need white light in order to be able to drive down a motorway, whereas white light in a residential area helps you know more what's going on around you? But we also understand how the eye works and how humans actually see light. And we've heard discussions on that earlier today as well. From a human point of view, we've got the rods and cones that allow us to see, but what we're really understanding now is what's called the ganglion receptors in the eye. They're sensitive to blue light, and they will trigger you to be awake, and so forth. They're linked to the body clock. So there is concern building up in the industry about how we actually understand this and actually understand how lighting will affect people. That's very good if you're going down a road. The white lights help keep you awake and everything else, but not necessarily if you're the resident in one of the houses, depending on how the lighting's been designed. And we've obviously heard earlier about the different eye responses of various aspects of wildlife. Within the lighting industry, we've used a lot of research by a chap called Alan Alton, who used to work at Hertfordshire County Council many years ago, and it's nice to see that what he was saying is that orange light has a negligible effect on wildlife, and the whiter that light source gets, the greater the effect. And that seems to be borne out through what we've heard earlier today as well. But from a human point of view, trying to understand the orientation of what you're going through, it's a matter of also understanding how these lights and light sources affect what you see. What you've got there on the left is a gnome under normal daylight. Top right, the normal joke in the institutional lighting professionals is, because we do like a drink, is that this is after a few drinks and in the gutter. But on the top left, you've got low pressure sodium, no colour rendering whatsoever. You do not see the colours. Bottom left, we've got high pressure sodium. You've got a little bit more colour rendering. Mercury, it changes the colours totally. And in the old days, if you were in a car park and it was lit with mercury lights and you had a brown car and you went back, it had become green and you had trouble finding it. And of course, white light, the metal halide, shows colours up very, very well. But what we also understand now is that if we light a road in high pressure sodium, and we stand you on a corner, that road there is lit with high pressure sodium and this road is lit with white light to the same lighting level, the photometer is showing the same level, you will tell me that the road in white light is brighter. The standards now require us to compensate for that, so we actually design to a lower level if we're using white light, so it is seen to be the equivalent level of the high pressure sodium. So it is an energy reduction point of view, but that is what it looks at, energy reduction, doesn't necessarily address the environmental aspect that we've got to look at. LEDs also come in a range of colour temperatures. We go from what's called comfort through to sort of the green, efficient one, through to what's more perhaps called cold white, a much higher colour temperature and has a much higher blue content, and it can affect how people feel within those environments. But what we're trying to do is understand the task and try to light just the task. We don't want backlight. We don't want spill light. There are cases when backlight is required, a bit of light onto the footpath, maybe a little bit of light just to help people see to get up to their driveway, up to their front door. On the other hand, they could get a good porch light. But we're trying to stop spill light and also really limit the light that goes up above the horizontal, because it's that light that starts to cause sky glow and other effects. This picture is more there to address light nuisance aspects, because it shows light intrusion into the window, source intensities towards the observer, and what might disturb you as a human enjoying your own house and all the rest of it. But simply by controlling the light spill and where the light goes, we can make sure that we are minimising the effect on the wildlife. Now what we've got to do is, we've got our light sources, but we've got to put them inside the right luminaire to control where the light needs to go. What we've got on the top right there is a standard bulkhead fitting. Someone used that in a village, lots of complaints. They're changed to the one that's lower down, just puts the light down on the floor, just gently lights the footpath, does the problem, doesn't shine light everywhere. But it's putting the light in the right luminaire and the right reflector system, so it actually distributes the light as efficiently as possible. The table there is from the Institutional Lighting Professionals Guidance on Obtrusive Light, and also CIE 150. What it does is it defines the areas from E0 to E5, so we've got protected dark skies landscape. And that says you will not put lighting in there unless it is absolutely necessary, and then in which case it's got to be very, very tightly controlled. Takes into account all sorts of other factors within that area, but it really means we can light, but we've really got to tie it right down. And then it just goes through sort of more rural areas through to the middle of the city, where it is quite reasonable to have a bit of still light going around and stuff. You want to feel safe walking down the street and appreciate the area and what is happening around you. But really it is the right choice of the luminaire to direct the light onto the task. And also lower is not better. The lower we go, the more we've got to shine light horizontally and maybe upwards in order to achieve the task. If we can go higher, and this is higher within restrictions of what it looks like in the daytime as well and everything else, and maintenance operations, but we can more focus the light exactly where it's needed and reduce the amount of spill light into the surrounding areas and so forth. You know, I've got a set of cue cards for timing. That's good. But what we're looking at now under the standards is, again, going back to understanding the task, but what it's looking like from highway lighting, car park lighting, etc., is we design the lighting to suit what is happening worst case, how busy the motorway is, etc. But we know come 11 o'clock the traffic on the motorway is reduced drastically. At Tesco's, the use of the car park is a lot less. It might be a 24/7 car park, but people are only parking near the entrance, they're not parking around the outside. We're allowed to reclassify the area in terms of lighting class, so we can actually dim the lighting, or in some cases even go as far as turning it off, because it might not, that area might be used as well. But we're reducing the lighting levels in order to meet the use, which is mitigating the environmental impacts, the amount of light that's perhaps going elsewhere, or that we can control as best as possible. So if we're looking at an assessment, it's good to get competent lighting professionals involved, either members of the Society of Light and Lighting or the Institution of Lighting Professionals. Don't go by isocontour plots, they're pretty useless. What you need to know is what is happening. If you've got areas where you're concerned you've got backlight paths, we need to have the vertical grids and understand how the lighting is playing on those trees. If you've got residents, we need to know what is the brightness of that light towards you. This can all be calculated and checked and all the rest of it. But isocontour plots, which are the normal thing that asked, really are quite meaningless in those senses. We need to know what is happening on the areas we are concerned about. And that can all be done through that. But it's also get the information for the design when it turns on. Lights and luminaires, lamps lose light over their life. The light output decreases, luminaires get dirty. Most designs are worked on the worst case scenario when you're going to change the lamps. And you may have lost 20% of the light output from the luminaire at that point. When you first turn it on, it is much brighter. That's the time you need to have the figures to do your environmental impact assessment, your planning concern, light nuisance, and what effect the brightness is going to have on the surrounding properties, etc., or animals. So what you need to do is you need to agree the performance, what is the task that's being undertaken, does it change during the night, etc. Have competent designers been involved that really understand the design, the photometrics, etc. Have we got the right calculations? Are we getting light levels onto the trees? Are we getting the intensities towards distant objects, etc., and not just having an isocontour plot What assumptions have been made as part of that design process, and then what mitigation measures have been built into that, etc., so that we can look at those things. But the most important thing that must happen, and it is happening under planning now, planning regulations changed as of September last year. There's a 6-step process now for planners to take into account external lighting as part of the things. It used to be picked up under nuisance. But we're seeing a lot of planners now putting in a clause that says the designer must come back and sign off the installation that it has been built as they've designed it and it's been set up and commissioned. We get a lot of contractors where they've gone and got what's called an asymmetric floodlight. It's a bit like this, but it puts all the light down, but they go and put it up like that, because that's how they think it goes, and then most of the light goes into the sky. We need to close that loop between those that have designed to make sure the installation has been commissioned and set up to actually operate as it needs to be. And that's the key signing off area we need to look at. So that's it. This is a photo from a recent street lighting PFI that's happening in the UK. The area in the foreground has been relit. Good optics, full cut-off, lighting just the task that needs to be. The city in the background they will get to. We can't address everything straight away because of budget constraints. But you can immediately see the effect good lighting design has had on that part of the city, and we're seeing this across the UK. It's going to take a number of years to get there, but we are getting there, and we appreciate what we need to do as part of our design process. So thank you very much for your attention. Thank you.